The National Water Agency of Singapore, (PUB), came up with the idea for the Deep Tunnel Sewerage System, DTSS, more than 20 years ago. It is a motorway for spent water that is vital to a small city-state with a growing urban population. Welcome back to our channel. We are back again with another new video of ours. In order to meet Singapore's long-term demands for used water collection, treatment, reclamation, and disposal, it captures water from residential blocks, commercial premises, and industrial estates and recycles it. With a network of tunnels, pipelines, water reclamation facilities, and ocean outfalls, Singapore's Deep Tunnel Sewerage System, DTSS, would entirely replace the sewerage infrastructure of the tiny island nation. The $3.65 billion DTSS, one of the most comprehensive wastewater management initiatives ever, will enable Singapore to accommodate an anticipated population expansion from 4.5 million to 5.5 million, reuse wastewater in useful ways, and rebuild land no longer required for sewerage works. WSP performed conceptual engineering, preliminary design, and program construction management services for the project on behalf of the Public Utilities Board, (PUB), of Singapore. The entire new wastewater infrastructure, including the north and south systems, was conceptually and formally designed by the joint venture. For the north system, which was finished in 2008, WSP provided program management for the construction of 30 miles, 48 kilometers, of tunnels completed under 6 design-build contracts involving 8 tunnel boring machines, contractors, and consultants from 11 countries, as well as assistance with tender documents for the design of the link sewers, the new Changi Water Reclamation Plant, and the Changi Outfall. The Public Utilities Board, (PUB), in Singapore is developing the Deep Tunnel Sewerage System, DTSS, a sizable integrated project, to meet the island nation's long-term clean water needs through the collection, treatment, recycling, and disposal of used water from businesses, residences, and industries. An Outstanding Engineering Achievement Award from the Association of Southeast Asian Nations as well as a prestigious Engineering Achievement Award from the Institution of Engineers Singapore were also given to the project. There are 2 stages to the project's development. The second phase is expected to start in 2016 and end in 2022 after the first phase's construction was finished in 2008. To transport sewage to 3 centralized water reclamation plants, the project entails building 2 lengthy tunnels, each measuring 6.5 meters in diameter and 80 kilometers in length. These tunnels will be built roughly 50 meters below the surface, WRP. The WRPs will process the sewage to create clean, premium reclaimed water that will be sold under the trade name NE Water. Through deep-sea outfall pipes, the treated wastewater will be released into the Singapore Strait. With a $2.70 billion investment, the first phase of the DTSS project was finished. It consists of a 48 km long deep tunnel system that directs water flows from existing gravity sewers to the Changi WRP in the east and the Kranji WRP in the north. The major components of DTSS Phase 2 are a cutting-edge NE water factory in the new Tuas WRP. When finished, the NE water facility at the Tuas WRP will supply 55% of the water needed in the area. The Tuas WRP's small design will require less people and energy. In order to generate less sludge and lower the cost of sludge disposal, advanced technology will be deployed. In order to maximize energy and resource recovery, Singapore's National Environment Agency, NEA, will construct an integrated waste management facility, IWMF, at the Tuas WRP site. This facility will combine used water and solid waste treatments. The current Ulu Pandan and Jurong WRPs and intermediate pumping stations will be shut down after Phase 2 is finished, and the occupied areas will be cleared for new construction. The DTSS project intends to reduce the island's used water infrastructure by 50% while also enhancing Singapore's water delivery and treatment system. The acreage previously occupied by the WRPs and intermediate pumping stations was decreased from 300 hectares to 190 hectares with the completion of DTSS Phase 1. The land should be reduced to 150 hectares by Phase 2. The area that is freed up can then be utilized for other, more expensive developments. The project is also planned to recycle spent water effectively and with little harm to the environment. The Tuas WRP's NE water facility will supply 55% of the water needed in the area. The DTSS Phase 1's planning, design, and construction were conceptualized and managed by CH2M Hill and its joint venture partner Parsons Brinckerhoff. One of the tunnels included in DTSS Phase 1's development was given to Samsung Engineering and Construction. The TMCR Group, Ah Boon Civil Engineering and Building Contractor, Sembawang Engineers and Constructors, Penta Ocean Construction Company, KTP Consultants, and AKS Lining Systems were additional contractors for Phase 1. The high-precision concrete tunnel lining for the project was provided by Hume Concrete Marketing, and the HDPE liners were purchased from Agro America. For DTSS Phase 1, Ho Lee Construction served as the plumbing and sanitary contractor. The Chani WRP received flow meters and transmitters from Yokogawa Engineering Asia and power and automation from AB. A joint venture agreement between Black & Veatch, B&V, and AECOM and PUB was inked in June to offer engineering services for the DTSS project's second phase. The B&V AECOM joint venture is receiving assistance from Ramble and KPMG for contract execution. The Public Utilities Board, PUB, of Singapore is creating the Deep Tunnel Sewerage System, DTSS, as part of a major water infrastructure project to help the nation's long-term clean water demands. To transport used water to 3 centralized water reclamation facilities, WRP, situated in coastal areas, DTSS constructs deep tunnels. The excess treated effluent is dumped to the sea through outfall pipelines after the used water has been cleaned and further purified into clean water to be distributed under the brand name NE Water. The project entails the construction of 2 substantial tunnels, each measuring 6.5 meters in diameter and 80 kilometers in length, to transport sewage to 3 centralized wastewater treatment plants, WRPs. 2 phases make up the project's development. In order to direct water flow from existing gravity sewers to the Chani WRP in the east and the Kranji WRP in the north, the first phase, which was finished in 2008, consists of a 48 km long deep tunnel system. Through a 30-kilometer south tunnel, 60 kilometers of linked sewers, the Tuas WRP, and a 12-kilometer deep water outfall, the second phase will extend the tunnel system to the west. For the second phase, Dextra provided 8 GFRP soft eyes for TBM breakthrough as well as 1,210 rock bolts for supporting the tunnel excavations. The NE Water facility at the Tuas WRP will supply 55% of Singapore's total water demand upon Phase 2's scheduled completion in 2022. The Tuas WRP will also process 800,000 cubic meters of wasted water each day, making it the biggest membrane bioreactor facility in the entire globe. Although many of the design requirements for the fully gravity-fed trunk sewer tunnels are fixed, the DTSS client team, which is a division of the Public Utilities Board, PUB, of the Singapore government, chose to award the construction contracts on a design-build basis, primarily to maximize the benefits of time savings, according to Chang Kok Meng, director of the PUB DTSS department. These big-diameter tunneling contracts represent a new undertaking for the PUB in terms of scope and size. Design, production, and delivery of the TBMs could proceed simultaneously with final design under the design-build model, reducing the entire project timetable by several months. The client has less direct engagement than would be available under traditional design-bid-build contracts, which is a drawback. Nevertheless, we were happy with the design-build process and will use it again in the future. The amount of maneuverability available to design-build contracting teams is constrained. The employment of some techniques, such as dewatering, is prohibited since the grade and alignment of the tunnels are fixed. According to Mrs. Ang, Deputy Director of the PUB DTSS Department, to eliminate the possibility of surface settlement, we mandated the use of positive closed-face slurry or EPB tunneling, and forbade dewatering without explicit consent. In order to improve the design of the chosen TBMs, confirm their excavation techniques, and foresee conditions, we also required the design-build contractors to conduct additional site investigation borings, supplement the geological investigation data we provided during contract tender, and prepare their own geotechnical interpretive report. Additionally, and in every instance, contractors had to have an independent checker assess their designs before submitting them to us for evaluation and approval. The plan has, for the most part, been successful. By both Singaporean and worldwide standards, the incidences of surface settlement above such a considerable amount of tunneling, through terrain that is considered to be hazardous, and beneath critical surface transportation infrastructure have been few and have had little effect. The most significant ground loss occurrence to date occurred at a launch shaft when one of the TBMs was mining through the tunnel eye into the drive. It resulted in a face loss depression on a roadway around 40 meters above, which required nighttime road closure to fill the depression and make the road completely usable once more for morning rush hour. Robert Marshall, project director for the CM2M, Parsons Brinkerhoff, PB, JV, stated, "We have had no additional big face loss occurrences and have not caused any serious settlement of either the roads or the MRT transit network, under which the DTSS tunnels pass numerous times. In order to prevent fatigue from the high thrust pressures utilized to pierce the rock and the high torque experienced in the soft and mixed face conditions, work has also been undertaken to reinforce the cutterhead support struts." Tae Ching Kiong, project manager for Semcorp, stated, "We did not anticipate needing so frequent interventions at the start of the project. Additionally, we anticipated performing the majority of the interventions in areas with entire rock faces outside. The opposite has actually been true in practice. Between 10 and 12 bids were submitted for each of the DTSS design-build contracts in 1999 due to fierce international competition, which led to extremely low prices. Only a small number of the proposals submitted were more expensive than anticipated. The owner of the DTSS will have purchased a 48-kilometer system of large diameter, 100-year design life infrastructure under the design-build procurement technique after it is finished, at a total contract bid price cost of $329 million. This is part of a $2 billion project that also includes a new, high-capacity treatment facility and a 5 km long outfall made up of 2-3 mi. Precast concrete pipes that were buried in seabed trenches off the island's southeastern shore. On the southwest side of the island, Phase 2 of the DTSS consists of a second proposed network of deep-level tunnels and a third sizable treatment facility and outfall structure. It won't begin construction until well after 2015, long after the existing Phase 1 experiences have been consigned to Singapore's own unique tunneling history. So, this was all about the video today. Thank you for watching.